Hey 271 class, this is Mr. Blevins, and this is a homework problem from the Chapter 3 homework set. So we're using implicit differentiation to find dy dx and then the second derivative. Alright, now this is the graph of something that is not a function. So we need implicit differentiation to find those tangent line slopes. So let's go through the process and find dy dx first. So we're going to take the derivative with respect to x. That's what this notation means. On the left-hand side, and to keep it equal, we'll take the derivative with respect to x of the right-hand side. So what we're saying here is these two things are equal. So the derivative with respect to the same variable should be equal. Alright, on the left-hand side, we're taking the derivative with respect to x. So we're going to say that this is just the power rule. So we get 4/5 x, and then if I subtract 1 from 4/5, I'll have negative 1/5. The same thing will happen with the y. The only difference is, again, when you do implicit differentiation, you got to remember the chain rule. So we're treating y as it's like it's dependent upon x. So we need to chain on a dy dx. Alright, or you can use y prime there, that's fine. And then the derivative of a constant with respect to any variable is 0. Alright, so there's our first step. Now we want to isolate this dy dx. Remember, we're trying to find what is the derivative, so we want to get that guy by itself, which means we will need to subtract this 4/5 x to the negative 1/5 from both sides. Alright, it cancels on the left and it leaves us with just the 4/5 y to the negative 1/5 times the chain rule there, the dy dx, equals, and on this side, since there was just a 0, we just get the negative 4/5 x to the negative 1/5. Now again, we're isolating this, so we're going to multiply by the reciprocal here with the 4/5. We'll get a 5/4. That'll multiply by here as well, so that'll all go away. We'll just be left with the y to the negative 1/5, and this is still a negative x to the negative 1/5. And then when we multiply or divide this away, it's the same thing as multiplying by y to the positive 1/5, which will make that cancel. And again, we have to do it on the right hand side to keep the equal sign true. So we end up with dy dx, x to the negative 1/5 times y to the positive 1/5, and we can simplify that further if we just use properties of negative exponents. So the negative can go down to the bottom, and this would become y to the 1/5 over x to the 1/5. The negative exponent can go down to the bottom and become positive. And now, since they're both the 1/5 power, we can just write it as y over x, and then raise it all to the 1/5 power, since the powers were the same. Alright, so there's our first derivative. Dy dx is negative y over x to the 1/5 power. Alright, now that's important. We're going to come back to this in a second. Now let's take the second derivative. The second derivative says take the derivative with respect to x of dy dx, which means I'm going to take the derivative with respect to x of negative y over x to the 1/5. Alright, so what I'm going to get on the left hand side is the second derivative, and this is that notation there, d2y dx squared. You can also do y double prime, would be perfectly fine with me if you did that. Now on the right hand side, I've got something to a power, so I need the power rule there. So negative 1/5 y over x to the, if I subtract 1, I'll have a negative 4/5. And now I need to chain on the derivative of what's inside. Well, the derivative of what's inside is going to need implicit differentiation. It's the derivative of y over x. So I have to use the quotient rule here, And I have to remember when I get to y that I need that chain rule part of it. So low d high, low is x, d high is going to be the dy dx or y prime, whatever you want to call it. So low d high minus high d low, the derivative of x with respect to x is just 1. So we just get a y there, and then all over low low, which is x squared. Alright, it's looking pretty messy. This happens a lot with implicit differentiation, especially the second derivative. It gets messy, and then we have to clean it up. Now, here's where we go back to what we had before. dy dx is the same thing as negative y divided by x to the 1/5. So I am going to replace that with negative y over x to the 1/5. Alright, so there is the exact same thing. With in place of dy dx, I have negative y over x to the 1/5. Alright, now notice I did pull the negative in there. That's okay because it's an odd power on the denominator there. So the negative being inside or outside wouldn't make any difference. So that's the same thing either way. Okay, now from here on it's just simplification. It's just understanding how to do algebra. I've said it before in this class. Calculus is like applied algebra, basically. You do a lot of algebra in calculus, almost more than you do in an algebra course. So what I'm going to do here is, this is the same base as this. I'm going to distribute, if you kind of see what's going on here, I've got like subtraction in the numerator. I'm going to distribute this in to the numerator before I deal with this x squared on the bottom. So I've got a negative 1/5 that's there. Y over x to the negative 4/5 times negative y over x to the 1/5. That's the, again, same base. Again, you can take the negative out with this. You know, you can basically, what I can do here is, it's like negative times a negative is a positive. And I don't have to deal with the negative, so I can distribute it there through as well to that second negative. And what I'm going to get is, this is still going to have the x squared down on the bottom. But I am multiplying this y over x to the negative 4/5 times this guy. And because the bases are the same, I can just add the exponents. So negative 4/5 plus a fifth is going to be y over x to the negative 3/5. Alright? And then I've got a minus y over x to the negative 4/5 times y. It's going to be a plus now because I distributed this negative sign through. So this becomes a plus. Y over x to the negative 4/5 times y. Now this is my personal preference. I don't like to deal with negative exponents if I don't have to. So this is a property of negative exponents as well, that I can flip the fraction on the inside and call this x over y, and that'll make this a positive 3/5. Alright, and then the same thing here. Y times, this will become x over y to the positive 4/5. Alright, and then just some further simplification. I can break this apart and call this x over 1 times x, the power on the top, I can associate it to both pieces in the fraction. So this is x to the 3/5 over y to the 3/5. Alright, and then same thing here, plus, call this y over 1 times this piece right here, x to the 4/5 over y to the 4/5. Alright, and then all of that is over x squared still, and this 1/5, let me kind of clear that up. This is being multiplied by the whole entire thing. All right, and then this, if you look, this is x to the, you can call this 5/5, x to the first. This is y to the 5/5, if you want to call it that. And what's going to happen here is it's going to become x to the 5/5, and 3/5 is 8/5. So that's x to the 8/5 over y to the 3/5. Right here we got a y to the 4/5, y to the 5/5. So again, subtracting because one's up and one's down. That'll leave me with y to the 1/5 up here, and then there'll be nothing left here. So it'll be y to the 1/5 times x to the 4/5, again all over x squared. Alright, and then another property of exponents and fractions. This 1/5 is just coming along for the ride the whole time. I can break all of this up right here into two fractions, meaning I can call it x to the 8/5 y to the 3/5 over x squared plus, I'm just breaking it up with this plus here, y to the 1/5 times x to the 4/5 all over x squared. And then this is just subtraction again. I'm subtracting this x to the 8/5 and this x squared because it's the same base, and I'm dividing. If you want to think of this dividing as multiplying by 1 over x squared, you can. But x squared, 2, is the same thing as 10/5. And so when I subtract here, I'll end up with x to the 8/5 minus 10/5 would be negative 2/5. So x to the negative 2/5. And let me write it this way. This is the way your math lab is expecting it to be written. This is 8 minus 10 is negative 2/5. And this y to the 3/5 is down in the denominator, so if I pull it up beside it, it becomes a negative 3/5. And then here, the y to the 1/5 is not being simplified with anything, so y to the 1/5. And then this x to the 4/5, once again, this is being subtracted from this. So 4/5 minus 10/5. Again, if I could call this 2 10/5. 4/5 minus 10/5 is negative 6/5. So I'd have x to the negative 6/5. And this is actually what my math lab wants you to put in there with the negative exponents and all. Even though simplifying typically means don't have negative exponents, this would be the answer that my math lab expects. So I've got it written in there 1/5 times all that stuff, and that's what they're wanting. Okay, now this is what I don't like about my math lab. This simplifies much nicer than what it is currently. So I'm done doing the blue work. That's what you're supposed to get to. If you continue this and you pull out the greatest common factor, because they both have y's, they both have x's. If I pull out the largest x, the x to the negative 6/5. Remember, when you're factoring it out, it's like you're subtracting this away from each one of these. And if I subtract this out, well, what is negative 2? The numerator, they have common denominators. So what's negative 2 minus negative 6? It's plus plus, that becomes a 4. So this becomes x to the 4/5. And let me move this. I'm going to pull out a y too. So, but that becomes x to the 4/5. Alright, now I'm also going to pull out a y to the negative 3/5. So I'm taking out the biggest in absolute value. So the y to the negative 3/5. If I factor that out too, well, it goes away here. So I'm just left with x to the 4/5 plus, now this one, x to the negative 6/5 is going to come out, so I'm going to lose the x's, but y? Y to the 1/5. What am I factoring out? I'm factoring out negative 3/5. So y to the 1/5 minus negative 3/5 would be y to the 4/5. Alright, now you may be looking at that saying, well, so what? Big deal. What does that have to do with anything? Well, that's the original problem. Way up here. X to the 4/5 plus y to the 4/5 is 96. So all this stuff in the box here, all of this is just 96. And so we can put that 96 over top of that 5. And we'd have 96 over, I'm going to put the 5, and then these are both negative exponents, so I can say that's x to the 6/5, y to the 3/5, and it ends up simplifying down very nicely, well, relative to the last expression that I had in blue up there that MyMathLab accepted. The problem is MyMathLab will not accept this. I'll show you. Alright, so there's my 96 over 5, x to the 6/5, y to the 3/5. MyMathLab says, nope, you didn't do that right. But it is correct. It is a simpler version of this. It's a simpler version of this derivative based on that first statement that we have being true, and for whatever reason their algorithm that they have does not take that into consideration when you factor that out, that pops up. Alright, so it won't let you simplify this x to the 4/5, y to the 4/5 back to 96, which is from the beginning. It's algorithmic, the way that they got it coded, and so they want you to stop right here at this step. Okay, now if you were to go on beyond that on the final exam or a problem where it's open-ended, showing your own work, I would be perfectly fine with either one of these. I would be ecstatic with either one of these because of the process and being able to do all this algebra, because it's so heavy, intense algebra. I would be ecstatic if you got either one. Okay, I just did want to point that out, that if you are simplifying beyond what MyMathLab is expecting, then they don't count. They don't give you credit for it, which kind of stinks.